Hey everyone, thanks very much. So like you said, I'm Matt Dailey. I'm a software engineer at Splunk. What I plan on talking to everyone about today is one of the features that we built while we were building out our own data pipeline framework for end users. So to start things off, I'll show you everyone's favorite slide, the legal slide. I'm just going to say that we're working on kind of a work in progress right now. So I'm not able to make any guarantees about what we will or will not deliver. So that's kind of the gist of this slide. But kind of to talk a little bit about myself. So I'm a principal software engineer at Splunk. I've been using Apache Flink for about 2 years now. And before that, I was working in the Hadoop ecosystem, doing a lot of HDFS, MapReduce, using HBase, and other big table derivatives. So kind of been working in that space for a while. So when we started moving over to stream processing, that kind of seemed like the next logical step from batch processing with things like Hadoop. So coming into Splunk, one of the projects that we wanted to work on was this project called the Data Stream Processor. So here's a screenshot that we have of the data stream processor. The idea behind it is we wanted to be able to enable users to create their own data pipelines that kind of exist on top of Flink. So this is a project that we have. It's currently in beta, splunk.com/splunknext. So the idea is that we want to be able to make the ability to make pipelines, send data through, route data, filter data, extract fields from that data. We want to make that consumable by any kind of end user, not necessarily people who have a software engineering background. So I really don't want to bury the lead on this because it's actually a really cool project. But the one thing that we're going to be talking about specifically is kind of what you see at the bottom of this screenshot. So you're kind of able to see the data as it's passing through this pipeline. You can see that the very first node is actually selected in the graph at the top. That's kind of the source we're reading from Kinesis. And you're able to see, okay, what are these raw records that are coming out of that? What do they look like at the bottom here? So the reason that we built this is it kind of starts with questions that the users have, right? So authors of pipelines would really like to know, why does my data look like that at the end of my pipeline? They ask a lot of really good questions, and more or less they end up boiling down into this one specific question. I have data coming in, but then I'm missing fields, or the fields look in a way that I'm not really expecting. What's happening inside of my pipeline? I need visibility into that. So after hearing questions like that, we had to ask ourselves, what do we need to build to answer these questions, right? So we kind of sat down and we said, okay, what things do we actually need here? So first we need a place to display the data. That's the user interface I already showed you. We need a way to store that data to display it later. We need a way for the pipeline to send the data to that storage layer. And we also need a way to test the pipeline during authoring. That's going to be one of the really important pieces I'll touch on in a second. And at the very end, we need a name for this feature. So when we came through with the design, we said, okay, we need a place to display the data. We want to build an API. We want this to be available through some kind of REST API, and then that can be what powers the user interface. The way to store the data, we said, okay, well, we can have some kind of ephemeral storage because the data itself is also going to be ephemeral. So the reason for that is because we said the key use case here is authoring pipelines, which either means creating a new pipeline or it means editing an existing pipeline. So the data doesn't need to be long-lived. It can be ephemeral. It can live for a little bit, then disappear. That's really nice. It ends up putting less pressure on us to actually store the data. We need a way for the pipeline to send the data to storage. Okay, well that means that we could actually make a function that we put inside of the pipeline that will send the data over to that storage layer, and it will also do something else to limit the data volume. Limiting the data volume is another important piece of this because we sort of realized if we're just sending all the data that comes in through a pipeline, users aren't going to be able to get value out of that after a certain point. There's really only so many records you can look at inside of the data table that's coming back and actually be able to make really good decisions based on that. So we said there's no good reason to capture more data than we need, so we might as well just limit the data that's being sent. We need a way to test the pipelines during authoring. So we decided, okay, let's run a separate pipeline for debugging. That means that you can have an existing version of your pipeline running in production, and you say, okay, I want to make some changes to it. Let's go ahead and give them the ability to run that pipeline separately. And then lastly, we needed a name for the feature, so we called it Preview, or Data Preview. So if we talk about what the general architecture is, this is kind of at an abstract layer. If we start in the top right, we have going through 1, 2, 3, 4. a client will end up activating a pipeline that goes through our pipeline activation API. That in turn ends up just activating the pipeline through the Flink job manager. The Flink job manager communicates with the Flink task managers that end up running the actual jobs. Embedded inside of the task managers as they're running our Flink code, those run what we're going to call preview functions. The preview functions are the functions that end up getting put in the pipeline, and those send the data to our storage layer here, which we also expose as an API, the data storage and retrieval API. There's some kind of data storage that it has as a backend to store that data, but it allows users to retrieve that data as they need it to show in that data table we had in the UI. So if we take this general architecture and then we say, okay, well, like, how would we actually implement this in a first run? Let's try to make it really easy. So the first implementation that we created, the data storage and retrieval API, actually stores the data in memory. So as I'm sure you're thinking, there are a couple limitations that adds, right? So if we're storing data in memory, that limits the amount of previews that we can actually run without overloading the data storage and retrieval API's memory usage. So that's one of the major limitations that you'll run into pretty quickly. The other limitation for this is that means that the data storage and retrieval API cannot be scaled out. The reason for that is because if you do something like load balancing between multiple replicas of that API, then each one of those replicas will have a fragment of the data. That becomes a real big problem because then when the users, the clients, try to actually retrieve that data from the API, they'll get the same fragmentation. Multiple requests to that API, then they'll get different data. It'll be very confusing. So that's why we couldn't scale that out initially. For operational reasons, we really wanted to achieve that. We really wanted to get multiple replicas for that data and storage and retrieval API. So that's kind of why we came up with the next level of the implementation. So the second level of the implementation, we said, okay, well, maybe we should use something else like S3 to store that data. At this point, you might be wondering, ooh, S3, is that really the best choice here? So S3, you might think is a strange choice because what we really need here are kind of fast reads, fast writes. The data storage we said was ephemeral, so maybe something like memcached or Redis would be a good decision here. And we haven't explored that yet. But the major reason that we chose S3 for the next version of this is mostly around operability and maintainability. We already have a lot of experience with S3 on the team. It's already part of our stack. There's a process we have to go through if we added a new piece of software to the stack, so that's why one of the things we really wanted to get to was being able to use multi-replica for that service. So we said, okay, well, let's just use S3 for now. It won't take too long to implement. We'll be able to move forward. So that's something that we're currently working on, should be coming out pretty soon. But the big question is, okay, well, how do those preview functions work, right? If I have a pipeline that I've already written, here we've got an example. It's kind of a simple example, right? We have a source reading data. Let's say it's from Kinesis. We have it branch, goes into two different filters. One of those goes through an extract regex, pulls fields out of the data, and then both of them end up going to sinks. Let's say they're going to different topics in Kinesis. So how would we actually take this pipeline that a user has already written and then really transparently turn that into a preview pipeline? So we're going to have to do a couple of things here. So the first thing you will probably notice is that we cut out those sync nodes. So the sync nodes we have to pull out because we really want to make sure there are no side effects when running one of these preview jobs. So at this point, we might need to take some time to define, okay, what do we think is a sync node? You probably would think of something obvious like, okay, well, if I'm writing out to Kafka, I'm writing out to Kinesis, I'm writing to a Splunk index, any of those things would definitely be syncs. They all have side effects. But we would also want to define that a sync could be any other kind of function that has a side effect, because we really want to make sure there's no side effects to this. So if you have something that, if you have a function that might just be writing to a database as a side effect of like, oh, I saw a record, I'm going to write it to a database, but I'm also going to pass the record on. We would also want to define that as a sync, because we want to make sure when we're running this preview pipeline that we wouldn't have those side effects. So that's kind of the first thing, making sure that we cut out the syncs, cut out the side effects. The second thing that we do is that we add in these preview functions. So preview is a function that we actually implement using Flink's rich sync function class. So like I said here, I have the little asterisk saying preview nodes are also syncs. That's an important implementation detail because if you don't have functions terminated at syncs, Flink will complain when you try to activate the pipeline because it'll realize, oh, you have parts of your pipeline where the data's not going anywhere. So we made sure that we incorporated that. So if you want to look at the actual implementation for preview, It's actually pretty simple. So like I said, preview sync extends the rich sync function. The rich sync function gives you the open, close, and invoke method. The open method we have here, it really just makes an HTTP connection to the data storage service. I have HTTP in parentheses here because we chose HTTP. You could really make that any other kind of protocol based on top of TCP or anything like that. The close method then also just closes that connection when the function exits. So all that does is close the connection to the data storage service. But now the invoke method might be the interesting part. So on invoke, that means that if a new record came in, it'll increment the count of the records that it's already seen. If the preview function has hit the upper limit, which we set at 100 right now, this is the limit we talked about that users can only get value out of so much data, then do nothing. Don't omit the record if we've already hit that limit. So otherwise, if you have not hit the limit, then go ahead, JSON serialize that input record, send it to the data storage service. So at that point, it'll end up in the data storage service, and the clients will be able to retrieve that data and take a look at it. So there's kind of a lot of other implications about how we've implemented this preview function, right? So one question you might ask is, what about checkpoints? If you haven't used checkpoints before in Flink, checkpoints allow functions to recover state following a failure and a restart. So we currently don't have checkpoints implemented. The problem with that is if a checkpoint function restarts, then that counter that it had that goes up to 100, that'll end up getting reset. Okay, that's kind of a problem because now when the function restarts, it might get sent the same data that it already saw, or it might get sent new data. Either way, the preview function is going to send data to that data storage API. So at that point, you could possibly have duplicate data. You could go over the data limit. So that's why you have to also enforce the limit of 100. You have to enforce the limit of 100 records inside of that data storage API as well. And then if you're talking about checkpoints, let's also talk about save points. How could we leverage save points? So if you haven't used save points before, save points are a special kind of checkpoint, and you can use those to stop and resume your pipeline. That's pretty cool in this use case, because what that means is you could actually you could create a save point when you start the preview pipeline, run through some data, the user sees it, goes, okay, I know what's wrong with my pipeline, make a change, and then they could run the preview again, this time using a save point that they had already created. So they would actually play the same data through. So if you're using something like a Kinesis source, the save point would end up saving the offsets from Kinesis. That way you end up reading the same data from Kinesis. And then you'd be able to see, okay, has the data flowed through how I expect now inside of my pipeline? So that'd be another really good improvement that we can make using save points. Another question we get asked a lot is, what about low cardinality data? So low cardinality data really just means data that arrives pretty infrequently. So once an hour, once a day, something like that. If you're running your preview, chances are you're only going to be running it for a few minutes. Data will flow in, you'll get your 100 records for each of your functions inside of your pipeline, and then you'll say, okay, and stop it. And then if you're looking for this kind of infrequent data, it'll never show up, or it'll show up if you get really lucky. So how would you actually go about running this kind of data through your pipeline in preview? So one option is to do something where you would maybe have to do something like importing the data. You would have to kind of have a snapshot of that data somewhere that you could use as an example, some kind of exemplar for that type of data. And then you could say, okay, well, I'm going to use that data, send it through my pipeline, through the preview, and see how it acts inside of the pipeline. Now, if we're kind of doing this offline with the import data, we very well could do something where we integrate that into a kind of automated testing framework. So then that might even work even better. You could do things like making assertions about it, making sure that the data is going through how you expect. That's interesting because it also moves away from kind of our initial value proposition, which is around sort of making data pipelines available to everyone, people who aren't software engineers. But for kind of power users, that's probably a really good thing to make available. And so then the other thing you'd probably want to extend this to is, can I use this same idea for my production pipelines? I have a production pipeline running. It's reading data consistently. Everything looks right. But I'm getting data that I'm not expecting. Can I go ahead and just turn this on for my production pipeline as well? And so we haven't done this either, but the same architecture should probably work for this, right? A couple changes you'd have to make to the algorithm. You wouldn't want to remove the sync nodes because you still need those in the actual production pipeline, but you would still want to add in things like the preview nodes to make sure that data gets shipped back. The other complication here is, what actually happens around the storage and retrieval API? Because you again wouldn't want to store all of the data, but you probably also wouldn't want to limit the amount of data that's being sent. So when a user goes and says, okay, like I want to see what the data looks like inside of my production pipeline that's running, you'd probably want to do something like return them the most recent 100 records. Okay, here's what we see right now. Here's a snapshot of the data. So that would require changes to the kind of the data structures that the data storage API would actually use. Right. So kind of to summarize, the architecture really wasn't too difficult. The implementation ended up being a lot easier than we thought. For people who are implementing this, I know that when I started working on the implementation for this, one of the things that I was really worried about was that entire thing about rewriting the pipeline. Because that was kind of a big area. I said, I have no experience in doing this. It ended up actually being really easy. At Splunk, one of the things that we've created for the actual pipeline definitions is that we have our own abstract syntax tree. And then we actually have a bunch of operators that run through that. And then what they do is they're able to translate that into a Flink job. So having that made it really easy for us to just kind of stick another operator into that tree walker. And then it goes ahead and translates the job and then does things like finding all the sync nodes, pulling them out, finding any nodes that aren't syncs, adding the preview function on top of that. So I want to say that that was pretty easy for us because we had that infrastructure. If someone else wanted to implement this, that's probably going to be one of the bigger things you need to think about. Okay, how am I actually making my pipelines using the Flink API? Where can I hook in to do that rewriting? So that might be one of the big problems that you have to run into. But overall, I think we were able to deliver pretty quickly and pretty easily on the things that we wanted, that way users could actually go ahead and use the system. We made the API, made the user interface on top of it, had a couple different ideas for the ephemeral storage. We had one implementation that worked. We were able to get it out to users pretty quickly, and then they were able to see it. It demos really well, very important. But we were able to add in the function that actually sends the data, limits the volume. We were able to figure out how to run this as a separate pipeline, really important, and we came up with a great name. So overall, thanks for listening. That was pretty much the whole presentation. Like everyone else you probably heard, we're also hiring at Splunk. And the other thing before I put into questions, I definitely want to put up some acknowledgements from the other people on the team who helped make this happen. Joey Echevarria is one of our architects. Sergey, Yassine, Sharon, and Bashar are software engineers that helped work on this, and Maria is our documentation expert. So thanks to everyone else who did this. And so now I think I can open up for questions.
Hi, I'm just wondering, when you say they're using preview to query the data, is it like query the raw data, or you actually add more features to actually do aggregation and all those on top of it?
That is a good question. So if we go back to like the screenshot, for example, the data that's coming through here is the data that you see at the bottom of the screen is what the records look like as they exit a function.
Yeah, so that's the raw events, raw
yes. Yeah, there's no aggregation here, there's no sampling done here. Those are things that we could add in. We could also add in actual functions that do things like sampling, depending on use cases. And then what you would be able to do is just look at the output of the sampling function, for example.
So the reason why I ask is, like, for example, I want to run my, for example, one query job, right? And I change it, I want to say, okay, for like a summation, the value should be still 100 is instead of 99 or 101. By looking at the raw data, it's a little bit hard. Is like,
okay.
Right? If it's a preview that I can actually submit a function, say, please do the aggregation for me on this column or some of the field, that would be easy. Are you guys thinking about doing that in the map roadmap? So one of the functions that we actually already have available is aggregation. So you can do aggregation where you do sum, min, max, a couple other functions. So what would end up happening is on this canvas, one of those boxes would be an aggregation function. And then you would just click on that function, and then you would see the results of the aggregations. Does that answer the question? For user-defined aggregations, I don't think so. There's sort of a longer story about like user-defined functions, like custom functions and how that works. But yeah, that's definitely something that's on the roadmap.
One more.
Is
this something you could use for like alerting, for example, like automatically paying attention to what kind of records you're getting and set a threshold if you see a number that's outside of what's normal, kind of automatically?
Yeah, so that's another thing that's on the roadmap for the data stream processor is alerting specifically, figuring out, so a common use case is perform an aggregation over some period of time, output that, okay, is this value above or below some value, okay, alert on it, right? And that's definitely something that, yeah, it's on the roadmap.
All right, thanks, Matt, for this great talk. Yeah, the next talk is up in 10 minutes. Yeah, thank you.